So in our previous lecture, so we discussed about the empirical estimation techniques. So and then we discussed about the COCOMO model, which is a heuristic estimation technique. So now today we will discuss about COCOMO 2 model. Okay, but before I go into COCOMO 2 model, so I need to complete. I know we need to have a discuss a little bit about this complete COCOMO model where we stopped in the last lecture, right? So now basic and intermediate model. So part of your basic and intermediate model, what they assume the whole software, whatever you are going to develop, so as a single homogeneous entity. That means everything as a equal. I mean, each and every subsystem is considered there as a equal. So they have assumed that, so each and every subsystem have similar characteristics, but it is not true in the real world, right? So usually your different subsystems will have different characteristics, right? So one subsystem may be considered as an organic, the other may be considered as a semi-detached, or the other module can be considered as some subsystem considered as embedded, right? So now, and also, so each and every subsystem will have different requirement reliability. I mean, they have a reliability of, I mean, requirement of different reliabilities. Okay, as well as the team which is going to develop a particular submodule, sometimes they have some prior experience, or some of them will not have prior experience, right? So everything needs to be taken into account when you are going to develop, when you are going to estimate uh, the using these are all models. So usually, so according to complete COCOMO, what it says is, so you will be taking into account the different characteristics of the subsystems, and then you get the estimations of each and every submodule or the subsystem, and then it is a sum of the estimates for the all individual subsystem. That is going to give you the overall project cost. Okay, effort. So now this is the way that so it is actually going to remove much of the errors when we come to a final estimate. Okay, and to further improve the accuracy of these results, sometimes you can take if at all you have any historical data, historical project data available, in the organization, you can take let's say some subsystem may have already developed, maybe considering certain number of parameters of the model. Now you can fine tune. Okay, that is what we say, so is to come up with a better accuracy. Now uh, as far as COCOMO is concerned, so it is not totally accurate. So it lacks full scientific justification. So because so we need to apply into a engineering approach, so because so when you are talking about any software project management, so usually we are going through an engineering approach, right? So you have various phases, right? You have various phases of the life cycle model, right? It's not the only one phase. It should not be considering only one phase, right? You need to consider all of the phases, right? So that's the way COCOMO is not suitable, because we need to go through the engineering approach. That means you need to consider every phase. Okay, so mostly we have not considered all of the phases there. Okay, so certain characteristics we have taken into account as part of COCOMO, right? So what says is, so companies consider computed cost estimates to be satisfactory if these are within the 80% of the final cost. Okay, so that means whatever the final cost that that will incur for our project, so whatever the estimations we have carried out, so that should fall at least within the 80%. Then only we can consider these models as a accurate. Okay, so now these are all completely gross approximations. Okay, so these models, so that is the reason why we are into now COCOMO 2 model. Okay, so we have seen now, So what is that? Basic, intermediate, and complete COCOMO. So these are the three, phases COCOMO has considered before. But now we are into COCOMO 2, which will consider certain other things, right? We'll talk about that. Okay. So present day software projects, whatever you have, they are very large today, large in size. Okay, and they want much of reuse. I mean, whatever the existing things are there, we try to reuse them so as to come up with the new software, right? And that's the reason why. So uh, we are into some sort of development where we wanted to go with a component based development, right? That means that there are certain number of components available. Okay, we try to use those components and then we try to develop. So, and that is, and the other way is, you can think of service oriented architectures, right? So we go for some sort of services, right? I mean, now you can think of today, cloud services. Okay, so now, so this is also part of, is it cloud, cloud services is an example of, one of the recent days softwares. Okay, now these softwares are cloud, these softwares are developed for cloud environment, right? Now that means, so they are service oriented, whatever that we want certain number of services. Okay, and we try to get those services. Okay, so that is a way how different service oriented architectures are nowadays, um, very important. Okay, and they are there now. So new lifecycle models and development paradigms are being developed for web-based and component-based, right? So today, this, most of the softwares are web-based and there are also component-based. As a result, there are new lifecycle models are coming up for these sort of softwares, right? Now, so during 1980s, so at that point of time, so these programs were not much of interactive. Okay, so it is just like, you can think of now. So today you have all graphical user interfaces. Okay, so those days there were no graphical user interfaces, only there were some sort of command mode. Okay, I know through commands only, so people were interacting with the system. So that's the reason why the programs were not that much of interactive. Okay, so effort spent on developing GUI part is often as much as the effort spent on developing actual functionality of the software. So today people say that, so the effort that we give for the GUI part is much more, I mean, it is almost equal to the effort required for developing a actual functionality, actual function of a particular software, functionality of the software, right? So that means, so GUI is also, has a greater, importance nowadays. Okay, but previously it was not like that. Okay, so in early 1980s, so these things was not thought of much importance, because that time GUI was not that much, the graphics were not supported. So we were, still into the developments, right? So that is the reason why. So today, but it is very much important, graphical things. Okay. So Boehm proposed COCOMO 2 in 1995. So he proposed COCOMO 2 in 1995. Okay, considering GUI things as an important part of the software developments. Okay. Now it provides three models to arrive at increasingly accurate cost estimation. So it has three different models. It considers the three different models. We'll talk about those. Okay. So now by using these three, so COCOMO, I mean Boehm, so able to give us better cost estimations. Okay, these models can be used to estimate project costs at different phases of the software product. That is what we say. That is what the different from the basic COCOMO and complete COCOMO and all, right? So here we try to give models for different phases. Okay, So we are trying to consider as many as number of phases as well as, okay, and also we are trying to consider graphical things and all, right? So that is the way that. So now it considers three phases as I told you, right? So it has three different model. So one is application composition model, the second one is early design model, and the third one is post architecture model, okay? So your application composition model, it is exactly used to estimate the cost for prototype development. So right, so whatever the before you develop any project, so you usually going through prototypes, right? So through these prototypes you wanted to understand the wanted to understand the complexity of the problem, right? You wanted to identify the risks, right? You wanted to handle those risks, so because of that those things, so you going through some sort of prototype, right? So now, so here it takes the cost of prototype also, okay, because prototype is part of each and every model you can think of. If you are talking about the spiral model, the prototype is there, right? Yeah. So a prototype is usually developed to resolve user interfaces issues, right? So usually, so here we try to use any of the risks that are involved as part of interfaces, because I told you, so main objective of this model, this Kokomo 2 is trying to consider this graphical user interfaces part, right? So how well the interface we are going to provide to the user, how much interactiveness we try to provide to the user through this graphical user interfaces. So these things are very important as part of this development, right? So whatever the prototype that will be really used to resolve the user interfaces issues, so that cost will be considered here as well, okay? And the second model here is early design model, okay? So here mostly it is all about the high level design. So I mean, so it is where it is we try to estimate whatever the cost really required for this architectural design phase, okay? So thereby we usually going to consider most of the reuse things, how we going to reuse the components, and also those things will be considered as part of early design, okay? So it is all design cost. Now you can understand there is a prototype cost and there is a design cost we are taking into account. Now the part of this post architecture model, so where we try to take the cost estimations during the detailed design and coding phases. So now here this is targeting only these two phases, okay? Detailed design. So second model only talks about high level design, okay? But your post architecture model does the estimations for detailed design as well as coding stages, okay? So post architecture model can be considered as an update of the Kokomo, original Kokomo. So usually, so we talked about the Kokomo model, where Kokomo model only considered, we have talked about, right, basic, intermediate and complete. So they only taken into consideration which one, which layers. So they have taken only the detailed design as well as coding, because you see your effort that you calculated based upon no, what can anyone tell me the past basic Kokomo and all model? So we have seen that, so the effort is calculated based on which parameter, which measure?
person
Huh?
month. Person
Line
month.
of codes.
Line of code. So
Can
line of codes is completely belonging to coding stage, right?
Yes.
So that is what we say. So that means here this Kokomo 2 also considers all of them. So apart from these two things, so 1 and 2 model are the extra models, okay? And the post architecture model is just an update of the Kokomo model, first Kokomo model, okay? So that is the way that you need to understand. So that is the reason why it is a Kokomo 2, okay? So it is the extended version of the previous model. Okay. So other two models help consider these factors. So like the first one, okay, application model, and we are talking about application and LD design. Okay, so these two models consider interactive and GUI driven. That is what. So they consider how much these GUIs were interactive, that are that are required. So how much interactiveness that are required, part of the software. GUI development constitute a significant part of the overall development effort, as I told you. So it is almost equal to the effort required to develop the functionalities also, right? As I told you. So interactive program concerns several issues that affect productivity, such as extent of reuse, right? So now, so usually, so when you talk about any interactive program, so so that also has an effect on the productivity. Okay, so the better the better interactive the program is, so you require, it will definitely will take more time. Maybe you take very creative people are really required, so you need to have much of reusability, reuse, you have to reuse many things, right? Then only you will be able to bring your program more interactive. Any doubts so far, students?
No, sir.
No. Okay. Right. So application, we'll talk about each and every model one after the other, right? So first we start with the application composition model, right? So it is based on, so as I told you, it is all about the graphical user interfaces and all, right? So that is the reason why. So we try to take the modules, okay, components, okay. So here we try to, here we try to count the number of screens, how many number of screens you really require, how many number of reports it is going to generate, and how many number of components that will be there part of, that will be there part of your software, right? So that means it is you see, when you are talking about GUI, that means screens means what? So you can see whenever you have any software, so you have different screens. Yes or no? So maybe you have a small window in the left side, maybe in the top right corner. Okay, maybe the top left corner you will have a small screen. In the below you may have some screen. So you displaying some contents in the right top corner screen, something like this. Okay, so this way you need to think of, okay, how many number of screens you really require. Okay, whether you want a one screen, two screen, three screen, as well as how many reports it is going to generate. That means how many documents, maybe uh, at a time it is going to create, right? And different components, right? Each of these components is considered to be an object. Now here, so whatever the components that you have, like the each and every component will be considered as an object. Here we'll talk about how we going to, because we are going to compute something, the number of objects. Okay, here that is the reason why each and each and every component is considered to be an object. Okay, and these are used to compute the object points of the application. Now we are at last we are going to find the number of object points. Okay, so you have 10 components, let's say, for example, in this case, so then you will have 10 number of objects. Okay, so based upon these objects we exactly compute the cost. Okay, so this is the way that we are going to do. So now, so usually the effort which we estimate using this application composition model, so follows certain number of steps through which we will try to estimate, right? So the first step here is, first we try to estimate the number of screens that will be required. Okay, number of reports will be going to generate, and how many number of modules. Okay, from the analysis of SRS document. So you have the SRS document, from which after analyzing the SRS document, so you first come up with a rough estimate of the number of screens required, the number of reports, and the number of modules. Okay, so first step you will be doing towards your effort estimation is this. Okay. Now the second step here, what you will do, so now then you determine the complexity level of each screen. Okay, how complex that particular screen you are going to develop or that is required. Okay, for the customer, right? And that report also as well as report. Okay, and these and rate these as a simple, medium, or difficult. So now, so the complexity of a screen, maybe you can say like this: it is a very simple screen. You need to develop part of your software. Okay, so you need a screen of medium, complexity. You need a screen of difficult, or you have 4 screens. Okay, one screen is of medium, the other 2 are very difficult, and the other one is simple one. You can say, okay, let's say you have four screens you are required. Okay, as part of that particular software. Now one is of very simple, the other one is of medium, the other 2 may be of difficult. This way you need to define. So based upon this complexity, now the cost will be computed. The complexity of the screen or a report is determined by the number of tables and views it contains. Now further, so we get this complexity. Okay. First, you will be saying that it is a simple, medium, difficult. So, right. So, this simple, medium, difficult can be classified based upon the number of tables and views it contains. Let's say you have you require one screen, and part of one screen maybe you need 2 views. Okay. So, you wanted to provide 2 views. Okay. Or you require 2 different tables. Okay. You require 2 tables as part of a particular report. Okay, or a screen also you wanted to have these two tables, right? In the table format you wanted to give the data, right, through a screen. So whatever whatever you wanted to give onto a screen. Okay, so now considering these number of views and tables, so the complexity will be decided. Okay, now you can see. So now now you can simply see, let's say screen complexity for the data tables you can see. So let's say for example, as part of your screen, okay, the number of views you may require is less than 3. Okay, if you require less than 3 number of views, okay, right, and the tables that will be there will be less than 4. Okay, right. I mean you require less than 4 number of tables, right? So that means maybe you have 1 or 2 or 3 tables. Okay, and the number of views you required is less than 3. Okay, so if you have a less than 3 number of views and the tables that you have less than 4, so then this can be categorized as simple. Okay, or you can see the number of views that you will have 3 to 7 also be considered as a simple. Okay, greater than 8 number of views, that should be their part of a screen, and you have less than 4, then you can say medium. So this way the classification will be done. Okay, so you can see, so the number of tables less than 8 and the number of views less than 3, then it is a simple. Okay, if the number of tables less than 8 and greater than 8 number of views, so then you can say it is a difficult. Okay, this way you will be classifying your screen complexity. Okay, now the third step what you are going to do is, so the weights have been designed to correspond to the amount of effort required to implement an instance of an object at the assigned complexity class. Okay, so as I said you, so whatever the component that you are going to develop, okay, so for those components, so you have certain number of weights. Okay, right, and these weights are based upon the complexity. Okay, so as compared, so now these objects will be given some number of weights. Okay, right. Now similarly For your report also, you can have the complexity like, okay, for the screen you have seen, so the number of views that you require and number of tables. Similarly, if you are going to for the report complexity, so you want it to same way, so you need to categorize the report as a simple, medium, complex, difficult, so whatever may be, right? So now what we are saying, usually part of a report, what will happen, usually you contain certain number of sections and subsections, right? So usually whenever you are writing, you are printing any document, so what you are giving any print off or you are displaying any report, okay, so what will it contains, it will contain number of sections, right? As well as, so part of your report, maybe you will have certain number of tables also you wanted to have, okay. So now based upon the number of sections and tables, now this can be categorized, okay. So let's say if you have a number of sections required is 0 or 1 and the tables is less than 8 or less than 8 or less than 4, still it will be considered as simple, okay. But the you have only 0 or 1 section, but number of tables that it contains is more than 8, then also you can classify this as a medium, okay. So this is the way that you can think of. Again, you can give the complexity for each and every report also, right? Now I said you in the previous thing, so for each of these complexities, okay, now whatever the object that you have, object means it is a instance of an, I mean exactly, you have a component or object, okay. So in order to implement an object or instance of an object, okay, so how much amount of effort really required, so that corresponds to a value, okay. That value is a weight, okay, that is a weight, okay. Now what you try to do in the part of fourth step, add all the assigned complexity of values for the object instances together to obtain the object points, okay. Now what I say, so let's say you have a so you have let's say 4 or 5 instances of a particular object, right? Now let's say you have a component, and for that particular component, so you require number of screens, maybe 4, or a number of what you say, reports maybe 3, something like this, right? And for each and every instance, so you have assigned some weights, okay. Now those weights will be, added together, okay. Let's say you have 4 object instances, so that means for first object instance, let's say you have given a weight of 4, okay. For the second object instance, maybe the weight you assigned is 3. For the third object instance, maybe the weight of 2. So then 4 plus 3 plus 2 will be the total number of object points, okay. So this is the way that we are going to calculate, okay. So the number of components that will be there, so usually these are the points given like this, okay. So these are the weights are given like this, okay. Let's say you have a object type, here is a screen, okay, and that particular screen is a very simple one, so then you will be giving a object point as 1, okay. So now if the screen, and it is considered as a very medium screen, medium complexity of, I mean screen of very medium complexity, right, then the weight will be 2. So difficulty 3. Similarly for report also there are points, okay. So now, so as I told you, so let's say if you have 3 instances of screen, okay, and the first instance is simple, second instance is medium, third instance is difficult, then what will happen? So what is the number of object points for the screens? So it is 6, because you have 3 instances and you have 3 different types, okay, classifications, right? So similarly report also, so the number of screens, the number of reports that are part of a component, so that will be added together to find the number of object points, okay. So that is what done, carried out, part of fourth step, okay. Now the fifth step, where what you would try to do, so is when you are going to, as I told you before also, so for your here also we are going to consider what, So reusability, right? So certainly you wanted to reuse certain, you know, certain percentage of, part is has will be reused, okay, in the system, okay, whatever the system that you are calculating for, maybe you will have certain percentage of reusability, okay. So now, as I said you, so by taking this, now you try to calculate new object point, okay. So the new object point will be calculated how? So whatever the object points you have obtained, the total number of object points that you carried out in the fourth step, okay, multiplied by 100 minus percentage of reuse. Let's say you wanted to reuse how much? You wanted to reuse 40%, okay, you wanted to reuse 40%, okay. So then that 100 minus 40 should be deducted. That means, so 60% of weight are given to object points, okay, 60% of weight to given to object points, right? 100 minus 60%, so 40. So that means 40% of the object points will be calculated. That is what exactly going to give you the new object point. Clear? Any doubts so far, students? Should I think you are all getting everything?
Yes, sir.
Right. So once once that new object points are calculated, right? So now the system where what do we try to do? We try to determine the productivity. Okay, how much uh, productive, how much productivity really required? Okay, for this software.
Room number 306 किधर है?
306, maybe that side also. So we try to determine the productivity, right? Which depends on the experience of the developers. You see, so the productivity will definitely increase when you have very experienced developers, right? So as well as the maturity of the case environment used. That means that kind of tool that you are going to use, okay? Case tool that you have used, okay? So as I told you before also, right? So if the same program is given to two students, one is a very good programmer, the other one is a not that much good at programming, right? So definitely I told you, so you require, one will take maybe 6 hours to complete, the one who is very poor at programming, the other one may be going to develop the program within 1 hour, okay. So likewise, so the productivity also increases or decreases based upon the kind of experience of the developers, the kind of experience the developers have, and and if at all they are using any tools also. Like I told you an example of a integrated development environment, IDE. Okay, I told you, right? One is writing using a simple notepad, the other one is writing using some IDE, maybe the NetBeans, Eclipse, these sort of IDEs, right? So you have seen, right? So the productivity is something like this, okay. So developers experience may be very low, nominal, high, very high. That means, so developer experience is very high, and the case maturity tool that you have used is very high, okay. Then you will be going to get the productivity of 50, because you have now used the most resources, good resources, okay. So because the developer's experience is very high, as well as the tool that you are using is a very recent tool that is available in the market, okay. So similarly, in a high case, so you will have 25 points, okay. So nominal 13, okay. So if it is a low, then you are going to get this 7, okay. Very low, then you have 4. So this way, so the productivity can also be given, okay, calculated, okay. So if these productivity are there, so then now what you need to do is, so finally you need to estimate the effort, right, in person months, okay. So that is computed using the NOP by productivity. So whatever the no new object points that you have obtained in the fifth step, okay, so that is divided by the productivity. Okay, so let's say the productivity here is so if you have used the developer's experience is nominal and the case maturity is also nominal, then that is a 13. Okay, now that will be divided by 13. So this is what exactly going to give you the effort. Okay, so this is part of application composition model. Right, now you can understand, right? So what you say is here whatever you are going to get, so usually so as part of this, okay, so how we are trying to you know convert these things is, so let's say you have a UFP points, unadjusted function points. Let's say you have a unadjusted function points, and those function points can be converted into source lines of code. Okay, so that can be converted into source lines of code. Usually, so for any typical programming environment, maybe whatever maybe the environment that you have taken, so each UFP, unadjusted function point, we have calculated that unadjusted function points in the during function oriented estimation, right? We have seen. A function point and future point part of. Okay, so each UFP point that you computed or you estimated, right? So now each UFP point would correspond to about 128 lines of C code. Okay, so that means you have, so how you are going to convert this UFP into source lines of code. Okay, so if you have a one UFP point, that means if you are using a C programming language, usually 128 lines you will get. If you are using C++, then one UFP point is equivalent to 20 lines of C++. And if it is a assembly code, so then one UFP point is equivalent to 329 lines of assembly code. Okay, so now, so of course, so these are all, these conversions also depends upon the factors like now the extent to which we have used libraries. Okay, we have used certain number of libraries, right? Now these that is also taken into consideration, right? So 7 cost drivers that characterize the post architecture model are used. Okay, so here as part of this, so even we try to take different 7 cost parameters. We'll talk about that. Okay, so and these are rated on 7-point scale. Okay, so now these all 7 cost parameters, so they will be rated on a 7-point scale. Okay, we will talk about, like in the past also we have seen, we have taken into account when you gone through functional function point. So I said you there are 14 parameters like cost drivers. So similarly here also we have taken 14 I mean 7 cost drivers for characterizing the post architecture model. Okay, so post architecture model is simple, so that is so here we will be taking 7, not the 14. Okay, and these cost drivers are rated on a 7-point scale. Okay, okay, so now then you are so this is about what we are saying is these all about. So the first one is up to this effort is estimated for the application. Okay, now this is what we are doing for LE design. Okay, this is what we are doing for LE design. Okay, now the cost drivers, as I told you, so one may be a product reliability, okay, and complexity. The other one is the extent of use, how much you are going to reuse the components, right? Platform sophistication. Okay, so that means what sort of you know platform you have used. Okay, and what personal experience, like as I told you, one is a highly experienced person, the other one is a poor in, poor at maybe the coding or maybe whatever the activity, right? So that means you have taken the personal experience also into account, right? And case support, whatever the case majority tools that we are using, right? And the schedule also, if you have any constraint of schedule, okay? So whether you wanted to want that particular uh, thing very early, okay, or something like that, okay? So these are the 7 cost drivers we have included, right? So based upon this, now you can calculate the effort here. So KLOC multiplied by product of cost driver. So you have taken how many cost drivers? 7. Okay. So whatever the, and these cost drivers are rated on the what point scale? Can anyone?
7.
7-point scale. Okay, so that means each and every cost driver will be given a point. Okay, maybe if you want a very reliable software, so then you will be most reliable, so in that case you will be giving the 0.7. Okay, you want very low level of reliability, so then you can give the value of 1, something like this. Okay. So now you have used 7 cost drivers, so values will be multiplied to the KLOC to calculate your effort, whatever the kilo lines of code you have, right? And that is what multiplied into this. Okay, so because you have gone through, right? So this is the way that you will be calculating the effort here, okay, in the early design. Now part of your post architecture model, I told you, so right, so that will be uh, that will be that will be actually for which phases that is going to consider take this post architecture model, the
Design and
estimation
coding.
for
Design and coding.
design
Detailed
detail.
design.
So it is a detailed design and coding, right? So it is similar to an updation of the basic COCOMO model and all, right? So here also the effort will be calculated using this sort of expression. Okay, A multiplied KLOC to the power of B and then multiplied by those 7 cost drivers. Okay, now here the A and B are the constants. Okay, here A and B are the constants. Okay, so A and B are the constants, right? So now these the what you say here is, so how this mechanism is completely different from the original COCOMO model, because it differs by the set of cost drivers, right? So there you have considered 14 cost drivers, but here we are considering only 7. Okay, and the range of value exponent, so here the value that we are giving to B is 1.01 to 1.26. Okay, right? So this is the way that the you get these constants, right? So you know, and then so we'll talk about this. So likewise, whatever the estimations that we have done here, 3 estimations, so altogether all of these estimations effort will be added together, so that will be the total effort. Okay, so using your COCOMO 2 model. Any doubts of our students regarding COCOMO 2? Should I go on to the other topic?
Yes, sir.
Okay. So now the other topic we will today discuss about is the staffing. Okay. So staffing means you understand, right? So how you going to recruit the people? Okay. So at different point of development, right? So how you need to estimate, right? You need to estimate that at different point of time during the developments. So how many number of people you really require? Okay, in order to accomplish that particular time, okay, or in order to accomplish that particular task, okay. So you need to have different skilled people. You need to recruit different skilled people at different point of time, right? Once effort has been estimated, the staffing requirement for the project can be determined. So first thing is that you need to get the effort. So that effort estimation is done using any of the technique that we have seen, okay. Once these efforts are calculated, effort is calculated in what units? Can anyone tell me?
So person months.
Person months, okay. So that effort, once this person month is calculated, now you need to say that, so you can determine what is the staffing requirement, okay. So because at different point of time, so how many number of people you really require, right? So for this, for this sort of estimation, so Putnam was the first to study this sort of uh, you know staffing estimation, okay. So this sort of problem, right? How many number of, I mean, what pattern you really want, okay, in what pattern you wanted to really recruit the people, right? So now Putnam extended the work of Norden, who had investigated the staffing pattern of general R&D type of projects, okay. So now Putnam was the first to study this problem in software, for software projects, okay. But prior to Putnam, Norden had studied, okay, or investigated, right, this sort of staffing pattern for what sort of projects? So R&D type of projects, where research and development type of projects. They are not the actually software development kind of projects, okay. That is for the R&D type of project. So he studied prior to Putnam, right? Now Putnam actually extended the work of Norden. So whatever the Norden carried out, now he extended that work onto the software projects. That is what we are trying to say. Clear? So now first we will see Norden's work, then we will get into Putnam's work. Yes, Susri, you are going to ask something. Are you going to ask?
No, sir.
Okay. So Norden found the staffing pattern of R&D type of project is very different from that of manufacturing or sales. Okay. So he also very beginning, so whatever the staffing pattern he found for the R&D, you see R&D type of project means what? So it is a research and development, right? So research means we never know whether there will be any outcome or not, okay. So we just going by some sort of methodology, okay, and carry certain experiments, okay. Thereby you try to you just try to establish some sort of new new facts, right? So that means you start with a assumption, right? I mean, you have some sort of wild guesses about the prepositions, or I mean some guesses you will be doing, and based upon that guess and supporting some methodologies, you carry out your work, right? You never know what will be the outcome, okay. So but in case of software kind of projects, the we know what exactly we are going to do as part of the development, right? So this is the way that it is completely different, right? So now so manufacturing things means what? So you know that, let's say you are going to produce a particular soap, right? Or you manufacturing some object, so the manufacturing process is known, okay. How so almost it is known, right? So that is the reason why there is a difficulty, right? There are many unknown things here as part of R&D. So but when you are manufacturing something, so so many things are known before, right? So that is what we say. So in a sales outlet, the number of sales staff does not usually vary over time, okay. So now you can think of, it's a best example. So let's say there is a big bazaar or something like that, right? So if you take this case with big bazaar, so usually what will happen? So let's say so each of the floors, Big Bazaar has 3 floors, let's say. You have a three-story building. So now they have something like this. So in the first stories, so there will be 10 people. Okay, 10 staffs are required. For the second stories, another 10. Third stories, another 10. Okay, so now these 30 once recruited, unless or until one leaves that particular job, so the number of staffs that will be required is the same. It will not change over time. Okay, but in R&D or software kind of project, it is quite different. Okay, at different point of time you require different number of people, right? It's not that always you will have same number of people occupied. Okay, so the number would be constant and it would depend on the number of sales counters in a supermarket. Okay, so that is what exactly you explain. So let's say today you have a 10 sales counter, right? So you usually require 10 people. Okay, so unless or until you increase the number of sales counter, so this number will not increase. Usually these sales counters will not change over time. Okay, much of. So maybe sometimes it will increase. Okay, so maybe you understand over the time, maybe you wanted to expand that into 4 floors. Okay, or 5 floors. So then you require more counters, when you wanted to, expand your business. So in that case, little bit few people really required. Okay, more. But over the time, so usually mostly you require constant. Okay, so that is what you need to understand through this example. Okay, so the staffing pattern changes over time in case of R&D projects. That is what. Okay, during start of R&D project, the manpower requirement is low as activities of the project are planned and initial investigations are made. Okay, so it is also almost similar with the software project also. So as I told you, so in its initial days of the project, so usually you require very few people, right? So maybe very beginning you require an analyst, right? So the analyst will be inviting the people experts from the customer side, right? I mean if it is a customer side, so customer side will invite certain people from the developer side. So 1 or 2 people will be going there and taking out all the requirements, right? So usually few people are required at the very beginning, right? But as long as the time progresses, so usually the number of people are really required. Okay, so now when you are into the coding, so you require more number of programmers. When you are into the testing, so you require more number of testers, right? So likewise, so that means over time, so at the very beginning, so you require very few people, but when the time progresses, the number will increase. Okay, as project progresses, the manpower requirement increases until it reaches a peak and then gradually decreases. So what he says is, once it may be at some point of time you will see that more people will be occupied in the project. Okay, and then gradually the number of people will be declined. Okay, let's say we are going into the deployment phase. So by the time you deploy that particular software, usually you may not require all of the people to be there, okay, in the project. So they may be assigned to some other project, okay, if they are part of a particular company. Okay, so this pattern can be approximated by the Rayleigh distribution curve, right? So now this pattern is exactly approximated by the Rayleigh distribution curve. We will see how it looks like. So this is what exactly a Rayleigh distribution curve. Okay, so that means, so as time progresses, the effort per time slowly increases and it reaches a peak, and after that, this the required number of persons that decreases over time, right? So now TD your represents time at which you require more number of people occupied for that particular project. Okay, right? So that means at some point of time you will have more number of people. Okay, that may be the time at which you are carrying out a very complex task. Okay, so and thereafter slowly the number of staffs will be reduced. Right now this equation, now this effort can be, as it is approximated by the Rayleigh curve. So the equation is something, the expression can be this thing. So K by 2 TD square multiplied by t, multiplied by e to the power of minus t square by 2 td square. Okay, so this is what the expression derived by Norden. Okay, so where e is the effort required at any point of time. Okay, and this is what exactly going to tell you, right? The number of people, so how many number of developers at any particular time. Okay, so usually during during the development of project, right? So as I told you, td, so at time td, so you require maximum number of people required, developers required. Okay, so this way, right? So at every time point, so you know that how many number of people you really require. So this is what the approximation. Now where k is what? K is the area under that particular curve. Okay, so it is the area under that particular curve, and td is the time at which the curve attains its maximum value. Now you understand? So any doubts so far, students?
No, sir.
So this is the way that so your Norden actually approximated. So the results of Norden are applicable to general R&D projects, were not meant to model the staffing pattern of software development projects. Okay, so actually Norden, so this is what exactly, this approximation is exactly carried out for the R&D kind of projects. So he have taken many R&D projects and studied many R&D projects, and after that he approximated this particular R&D projects should require this sort of staffing pattern over the time. So this is what for R&D projects, but he was not carried out for, I mean, this activity, this approximation was not carried out for the software development projects. Okay, so now for this project, so Putnam actually extended this work by considering taking the large amount of software projects data, and then he trying to establish similar way some expression. Okay, effort estimations, right? So now, yes, any doubts so far, students?
No, sir.
So can I stop now? Because in the next lecture I will discuss about Putnam's work. Okay, today I cannot. Okay, so and also one more thing. So right, so this week also we will take similar way. In the last week we have taken the extra lectures. Okay, so tomorrow also you will have an extra lecture in that particular time. Okay.
Hello, sir.
Yes.
Is the timing of the extra will be like previous week?